Welcome to the first video in Unit 7. This is Introduction to Sequences and Factorials. Here are the objectives. Please make sure you get these in your notebook. A sequence is just a series of numbers. You can see here on the screen that we have a sequence 1, 2, 3, 4, 5, and it ends at 20. So this is a finite sequence. It actually ends. An infinite sequence would mean that it would go on forever. So the same sequence would be written 1, 2, 3, 4, ... That would be an infinite sequence. It would have no end. Occasionally it will have a rule at the end of it, but once again it's a variable, so it still indicates that it's an infinite sequence. The difference between a sequence and a series is that a series is a set of numbers, but it has pluses between them. So you're actually finding the sum. Once again, this is a finite sequence. An infinite sequence would just be something along the same lines of 1 plus 2 plus 3 plus ... plus n. That would still be an infinite series. Infinite. And then each one of these is a term. So each one of these is the term. So this is the first term. A sub 1 would be the first term. A sub n would be the nth term. Right? This is probably the 20th term, A sub 20. And so n then would be the term number. Can't spell it. Term number. N would be the term number. There's n number of terms in the sequence. The general form of a sequence or series uses the term number n. So for instance, here is the rule, the given rule. A sub n, the nth term, would be -1 to the nth power times n plus 3. So n then would be the term number. So if I was going to find a sub 1, I would say -1 to the first power is 1 plus 3. Negative to the first is still negative, so this is going to be -1 plus 3, which is -4. The second term, -1 squared, 2 plus 3, would be -1 squared would be positive, so this will be a positive 5. On the next term, if I have -1 to the third power, 3 plus 3, it's going to be a negative number and 6. And by the fourth time, you could probably guess that it's going to be a positive 7, then a -8, then a positive 9. And so you can see that the signs alternate. And it goes up each term plus 3. So it started at 4. So it started at 4. 1 plus 3 is 4. And then it goes by ones. Goes by ones. So then it would just keep going on and on and on. So then, if you needed to know what a sub 20 was, you could actually find that pretty easily. This determines the sign, so that's an even number, even power, so it'll be positive, that's 20. And then I have 20 plus 3, so that's going to be the positive 23. So you can find any term if you have it in general form. So using general form, you can actually use any kind of rule. Here's our rule. A sub n. A sub n is 2n plus 1 over n to the third. N is the term number, right? And it says find the first 4 terms in each sequence. So that's what we're going to do. A sub 1 would be 2 times 1 plus 1 over 1 to the third power, which is 3. All right. If I do the top part of this one, this would be 2 times 2, so there'll be 5 over 2 to the third, which is 8, which is 5 to the 8th. So basically all you're doing is plugging in the term number for n and solving. So you end up with 7 over 27 and 9 over 64, and you call it good. So once again, if you have a rule in general form, it's very easy to find the 10th term, the 282nd term. So for instance, the 10th term would be a sub 10 and that's just notation. 2 times 10 minus 1 squared, which is going to be 19 squared, and you're good. That, I believe, is 361. All right, the 286th term, 282nd term, 282, would be the same deal. I would have 2 times 282 minus 1 squared, and that would equal a big number. So once again, you're just plugging that in and finding a specific term. This is a different way to write sequences and series, and it's using recursive notation. Recursive notation uses the previous term to find the next term. It's missing the word here, next term. The first term, or a sub 1, the first term has to be given. The first term has to be given. So in recursive notation, it uses the previous. So for instance, the current term that we're using, a sub n, would be the current term. The next term would be a sub n plus 1. The previous term would be a sub n minus 1. Now here's a concrete example. For instance, if you have, I'm on the second term, a sub 2. The next term would be a sub 2 plus 1, which is the third term. The previous term would be the first term. So this part right here is just notation, and you can go infinitely in both directions. So for instance, the next term after this one would be a sub n plus 2, a sub n plus 3, and then vice versa. So a sub n minus 2, if you're going to the left, a sub n minus 3, on. And so that is what the notation looks like. So for instance, if I have a sub n is going to equal a sub n minus 1 plus 10, this is the previous term. Another way to write this, which is just as valid, is to say a sub n plus 1, right, is equal to the previous term. The previous term to a plus n plus 1 is a sub n plus 10. These mean the same thing. They mean the same thing. So for instance, you have to be given a sub 1. A sub 1 has to be given. So if a sub 1 is 2, right, then write the rest of them. A sub 2 would be 2 plus 10, which is 12. A sub 3 would be 12 plus 10, which is 22. A sub 4 would be 22 plus 10, which is 32, and so on and so on. But in order to get to the fourth term, you had to go through all these other terms. So recursive notation does not use the term number. It uses the previous term to generate the next term. This is a tough concept, but hopefully you will pay attention and see some examples coming up. So this shows a little bit of the differences between recursive and general form. These two right here are both recursive, and the reason I know is because of the notation. Even though this has the term number in it, this is the previous term to a sub n, so this is recursive. This one as well is recursive. Even though it has an n in it, this notation means find the term that's previous to this one, add 2 and divide by 2, and you get an answer. So on a recursive, remember, you have to be given a sub 1. You have to be given the first term, a sub 1. But if you're in a general form, here, in the general form, you would have just a n. You would not have a sub n minus 1, no previous term. You're actually using the term number in the formula. So for instance, this one, and I don't need to know what the first term is. I don't care. I'm just going to do 2 plus whatever the term is and get 12. But on this one, what I'm going to do is I'm going to take the previous term, add the term number to it, and get an answer. So I don't know what's happening here exactly, but here what I want to do is a sub, say I want to find the 10th term, A sub 10 would be the ninth term, a sub 9 plus 10. Well, what do I have to do? Well, I have to go through all the terms to get to the 10th one. Or I have to have some kind of formula. But using a general term, I can just put the term number in and I've got it. So it's easier to find it using general than it is recursive. You don't need to write this one out except just to look at what it looks like in terms of being recursive versus general. Now, some students have done factorial, some have not. Factorial is where you take a number with an exclamation point. And over here on this corner, these two values need to be written down. And the reason you need to write those down is because these are given. These are let 0 factorial equal 1 and let 1 factorial equal 1. And so that's just given. You need to know that. 7 factorial just means that you're going to take 7 times 6 times 5 times 4 times 3 times 2 times 1 all together. 3 factorial is 3 times 2 times 1. So if you were to divide 7 factorial by 3 factorial, you would have 7 times 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1. You can see that these three are forms of 1, so they cancel. So it's really going to be 42 times 20, which is 840. Okay. Another way to write that then would be 7 times 6 times 5 times 4 times 3 factorial over 3 factorial. The factorials will cancel, and you'll still end up with 840. So once you've learned the basics of factorials, then you can do all kinds of fun little math problems like this. For instance, 10 factorial is just going to be 10 times 9 times 8 times 7 factorial. And then on the top I have a 7 factorial. That's why I stopped there. 3 times 2 times 1. So you can see that the 7 factorial and 7 factorial will cancel. Another thing you can see is that the 3 is going to cancel with the 9. The 2 will go into the 8 4 times, and I'm left with 3 times 4 times 10, which is 12 times 10, which is 120. So a lot of these you can just do in your head. Here's the second example down here, is that I have 8 factorial. So I have 8 times 7 times 6 times 5 factorial. And then on the bottom I have 4 times 3 factorial. And then on top I have 5 factorial, which is going to cancel. I have 3 factorial, which is going to cancel, and then 2 times 1. So I'm going to go ahead and mark the 5 factorial cancels, the 3 factorial cancels, and then the 2 is going to go into the 4 2 times. And so I'll be left with a 1 in the numerator, and then I'm going to have 8 times 7 times 6 times 2, which is going to be 672, because I have that worked out ahead of time. I would love to tell you I did that in my head, but I did not. Oh, and I neglected to say, now that I've stopped it for a second, 0 factorial, remember, is just 1. So be careful, this is just 1. I kind of ignored it, but that's figured in as well. Okay, so you can use that same rule, factorial rule, to write these using term numbers. So for instance, n factorial is really the same thing as n times the next lower one, n minus 1, times the next lower one, n minus 2, times the next, until eventually you're going to get to 321, depending on what n is. Okay? N plus 1 is the same thing. It's the n plus 1 is the one greater than n. So I have n plus 1 times n, times the one less than, times the one less than that, and eventually it's going to get to 321. 3n factorial is the same principle, so I'm going to have 3n times 3n minus 1 times 3n minus 2 times 3n minus 3, and so on, so on, so on, until I get to 321. Now I can actually work a problem using this same procedure. So in the numerator, I have n plus 2 times n plus 1 times n factorial. And I'm going to stop there because in the denominator I have n factorial. So the 2 will cancel, and my answer will be n plus 1. Don't multiply them together, just leave them separate, times n plus 1. And if you ever get confused by them, you can actually put real numbers in there. If you do 6 factorial, right, 6 factorial is just n. So 6 times n minus 1 would be 5, times 4, times 3, times 2, times 1. Here are 3 problems that I'd like you to work in your composition notebook. The first uses a general form to write the first 4 terms. Find the 4th term using recursive, and then solve this, simplify using your factorials. See you in class.